Buenos días a todas y a todos. Vamos a dar paso a la segunda plenaria de hoy. Para ello contamos con una ponente internacional que nos va a hablar de anticuerpos ampliamente neutralizantes, que es un área de estudio que está generando pues datos muy interesantes en estrategias de prevención y de tratamiento. It's a great honor and a privilege to introduce to this audience the next speaker. Maria Caskey is Associate Professor of Clinical Investigation at the Rockefeller University in New York City. Dr. Caskey received her MD degree from the Federal University of Sergipe in Brazil. She moved to the US to complete a residency in internal medicine at the St. Luke's Roswell Hospital, followed by fellowship training in infectious disease at Cornell Presbyterian Hospital in New York City. In 2006, she joined the Clinical Scholar Program at the Rockefeller University, where she obtained a master's degree in clinical investigation in 2009. Her work at Rockefeller focuses on the development and clinical evaluation of novel HIV immunotherapeutic and preventive strategies. In the last year, Dr. Caskey led the first clinical studies with two of the most promising neutralizing antibodies, which were isolated from HIV-infected patients in her lab. These molecules have the potential to controlling viral replication and preventing infection, but also may target latent reservoir and therefore are attractive candidates for HIV prevention, therapeutic and cure strategies. Today, she is going to give us an overview about broadly neutralizing antibodies and their implications for cure and vaccine. I'm truly delighted to welcome Marina Caskey.
Thank you very much. This is a very kind introduction. Thank you for having me here today. And I apologize that I can't do this in Spanish, so we'll bear with me that the presentation will be in English. Okay, so I'll talk today not only about the work in our group, but I'll try to do an overall view of where the field of broadly neutralizing antibodies stand, but focusing more on potential roles for treatment and cure. So I'm not going to be talking at the end about a vaccine implication so much. So, so the HIV, during HIV infection, some individuals do develop neutralizing antibodies against envelope, which is the only epitope on the virus that is susceptible to neutralization. But the HIV envelope is not, it's a tricky antigen in that it's very sparsely expressed on the surface of the virus, and it's masked by a very thick shield of glycans. And on top of that, perhaps the biggest challenge to develop effective antibodies is that the envelope is very diverse. But even despite all of these challenges, during the course of the infection, there is this continuous interplay between antibodies and viruses, where there is an initial antibody response that induces changes in the virus that produces more antibody maturation, and so on and so forth. And this can go on for several years until a point where, in a % of individuals, they do develop antibodies that are called broadly neutralizing because they can have activity against viruses from many different clades. So even though these antibodies are elicited in this % of individuals, they are not of clinical importance. They're not of clinical advantage for the individuals in whom the antibodies develop because the virus in these individuals have already escaped from these antibodies. However, if we can transfer the antibodies to another person, perhaps we can transfer some of the activity in both suppressing viral replication and or preventing infection in individuals that do not haven't acquired HIV. So over the last several years, in the last 10 years or so, new cloning methods have allowed the identification of many antibodies that are considered broadly neutralizing. And these antibodies target many different sites on the envelope of the virus. And then I'm highlighting here antibodies that have entered clinical testing in the last 5 years or so. So there are antibodies against the CD4 binding site, which is here in pink, the top of the envelope spike, also in this area here that is the V3 loop, and then also antibodies that are that target the bottom of the envelope trimer. And then there are different versions of these antibodies. They have different potencies, and then they are now being tested clinically. So what this graph here is showing, so not every antibody is the same. So not only they target different sites on the envelope, but they also have different potency and different breadth. So these, if you listen to these presentations, you're always going to see these neutralization curves, where in the y-axis we are plotting the percent of viruses in a panel that included viruses from many different clades. And so this is the coverage that the antibodies have. And then this is the potency, so the concentration of the antibody that was required to induce neutralization, to block infection in vitro. And the colored lines depict these neutralization curves for antibodies that target 4 different epitopes. And then the yellow line or brown lines are what it would look like if we were to combine any of these 4 antibodies, use 2 of them in combination, and then what we would get if we combine 3 or 4 antibodies. So basically we see that if we combine the antibodies, we shift this curve to the left, so we increase both breadth and potency. So if we, with the double combinations, we can reach coverage of about over 90% of viruses. And then if we were to combine 3 antibodies, we can reach close to 100%. However, 2 points that we have to keep in mind is that, so this panel here was with viruses of many different clades. However, we know that not every dual combination or triple combination of antibodies will work the same in different regions of the world, because coverage varies depending on the clades that you are focusing on. So, the antibodies that might be best in the US may not be the same antibodies that would be best to use in sub-Saharan Africa, for example. And then in addition to that, most of these the in vitro characterization of these antibodies are by every group is done by these pseudoviruses. So these are laboratory strains that have inserted, they have the same backbone, and then they are inserted different sequences of envelope. So it is known that these pseudoviruses are typically easier to neutralize than a real virus that you would have in an infected individual. So it may be that some of these neutralization curves are overestimating the potency of these antibodies. And this is something that we are beginning to appreciate now that we are doing clinical studies. So when we think very broadly about these antibodies, we think that they can have roles in both maintaining antibody suppression, so during established HIV infection, but also as an alternative to the current PrEP. So, and why do we think that? Because these antibodies, they target HIV. They're not self-antibody against a self-antigen. So we expected that even long-term, they are expected to have a good safety profile. And also, like long-acting ARVs, they might have an advantage in terms of enhancing compliance. In addition to that, and this is where antibodies may differ from ART, we know that these antibodies, they also are able to engage with the host immune response, the host immune system. So therefore, it is possible that not only antibodies can clear free viruses, but they can also boost existing immune responses. And perhaps, either alone or in combination with other strategies, we could achieve ways of eliminating latently infected cells in the reservoir and then reshaping the immune response in a way that we could achieve long-term virologic control. And in addition to that, by doing these studies with antibodies, either for prevention or in infected individuals, we are learning a lot about how to design more effective vaccines. And then we are testing the concept that vaccines that would induce such antibodies could perhaps be effective. So, but the most important, or what's of most interest to us at the moment, is the fact that that antibodies differ from ART in their ability to interact with the host immune system. So what this cartoon is showing is the different ways that antibodies can have antiviral activity. So they, like ART, not like ART, but they can block free viruses that are circulating in plasma. But in addition to that, they can bind to infected cells that are expressing envelope on their surface. And by doing so, they can trigger ADCC and other FC-mediated functions that can then come and eliminate these infected cells. So they have the potential to target the reservoir. And when they bind with circulating viruses, they can form these immune complexes that are then presented to dendritic cells and then can boost host immune responses. So we can potentially see an improvement of already existing or inducing new T cell responses after antibody therapy. So what do we know so far with the studies that have been done with these new generation BNAbs to date? So to date, 9 different BNAbs have been tested in the clinic in small studies. And there haven't been any safety concerns in general, although there was a phase 1 study with 10E8 that was recently presented by the group at NIH, showing that antibody, when it was administered subcutaneously, it showed some local reactogenicity. So that study was now stopped, and then they're trying to understand what caused those local reactions. But aside from that, all the studies so far have shown very good safety profiles, including these 2 phase 2B studies that are being conducted with VRC01. They're called AMP study. In this study, they have completed enrollment, so more than 4,000 individuals have been enrolled, and then they received 10 infusions over a period of 18 months. So to date, 30,000 infusions of VRC01 have been given, both in the Americas and also in sub-Saharan Africa, without any safety concerns. The antibodies that have been tested to date, they have the expected half-lives of about 2 to 3 weeks that one would expect with a natural type antibody. And then there's also now new versions of these antibodies that include these mutations that are known to prolong half-life. And then the first published data comes from the VRC group with VRC01LS. And then they show that the half-life was increased by 4-fold by simply introducing these 2 amino acid mutations. So this antibody has a half-life of 70 days, which is a great improvement. And then the other thing that is one can need to think about is like is seen with antibodies against cancer or using cancer immunotherapy, anti-antibody responses can evolve over time. And then this could have both safety or pharmacokinetics issues. But so far, even in the VRC01 AMP study, that has not become an issue with these kinds of antibodies. So in our group, we work with these 2 antibodies, 3BNC117 and 1074. What this figure here is showing is how they bind to the HIV trimer. So just to illustrate that the 2 antibodies, they target non-overlapping epitopes. And then going back to that neutralization curve, we see that in red is showing that what neutralization coverage we have when we have the 2 antibodies in combination. So if we were to maintain levels between 5 to 10 micrograms per ml, we would have coverage of about 90% of different virus strains. So in addition to safety and pharmacokinetics, these earlier studies have tested the in vivo antiviral activity of these antibodies in infected individuals. And then here I'm just showing the virologic curves of the 3 antibodies for which there is data so far. So each of these plots are showing change in viremia over time after the antibody infusion that was given just once. So for the 2 antibodies, we see that for the 3 of them, we see that there is a transient decline in viremia of about 1.5 logs. And then over time, the viral loads return to baseline, which is not surprising because we are giving only 1 antibody. So like it would be expected with one ARV in ongoing viremia, there is selection of resistant strains. But these first studies did show that these antibodies, unlike the earlier versions of BNAbs, they have in vivo antiviral activity. And then there are all these other antibodies are now in clinical trials in viremic individuals. So we're going to be learning, hopefully soon, what their antiviral activity during viremia also is. And so we conducted a study where we gave the two antibodies together to ask the question, well, will we achieve viral suppression with the two antibodies and then prevent viral escape? And what we found is, this is a very small study. We had only 7 individuals. It has become very, very difficult to recruit viremic patients, particularly in New York, where the coverage, the rate of people being on ART suppressed has been very high. But what we found was that when we looked at all participants, there was this decline in viremia that was transient but more prolonged than what we had seen with a single antibody. And then when we looked at the 4 individuals that have completely sensitive viruses to the 2 antibodies, we saw the decline in viremia was down to now more significant than what we had seen with 1 antibody alone. And then this effect lasted for an average of 94 days. So in some of the individuals, for an average of 12 weeks overall, and in some individuals, this could be as long as 20 weeks. But there are 2 important caveats. So we did see a significant reduction in viremia, but we did not achieve full suppression, except in 2 of the individuals that had very low starting viral loads. So in patients that had viral loads less than 1,000 copies, we are able to reach undetectable levels of viral loads. So what this shows is that 2 antibodies won't be sufficient to bring a viremic individual to full suppression as you would have if you were to start triple ART. However, the other part that is interesting is that we did not see new resistance develop to both antibodies in these individuals, even when there was residual viremia. So that what's telling us is that the bar to resistance for one of the antibodies, which is the CD4 binding site antibody, seems to be very high, whereas selection for the V3 glycan antibody 1074 occurs more readily. So, so it may be that we can use antibodies in combination with 1 ARV, for example, and then we would achieve full suppression, or perhaps combinations of 3 antibodies would be more effective to bring it down to full suppression. Okay, so then the other part is, so we show effects in ongoing viral replication, and then can we use these antibodies to switch individuals from standard ART to antibody treatment for the same reasons that one would switch someone to a long-acting ARV. So a few studies have been done, and then here I'm just summarizing what's been found with 3BNC117 and VRC01, which is another, it also targets the CD4 binding site. So in this study, the individuals were all ART treated, they were doing well, they discontinued their ARVs, and then they received infusions of the antibodies, and then they were followed until viral rebound occurred. And what these Kaplan-Meier curves are showing is the percent of individuals that maintained viral suppression over time from discontinuing ART. As it would be expected in chronic individuals, viral rebound is expected to happen within 2 to 4 weeks after discontinuing ART. And then what we found in our study with 3BNC is that we were able to shift that curve by a median of 6 weeks if the individuals received 2 doses of the antibody, or 10 weeks if they received 4. So so we didn't prevent rebound from occurring 100%, but we are able to delay rebound from occurring. And this is in contrast to what was found with 2 VRC01 studies, where the time to rebound was a little shorter than what we found in our study. And then there are several reasons for that. One, it may be that in our case, we selected individuals to the best of our abilities at the time for sensitivity to 3BNC, whereas in the VRC01 study, there was no pre-screening. But it's also known that VRC01 is a less potent antibody than 3BNC. But the bottom line here is that even though we were able to maintain suppression for a period of time after they discontinued ART, we were not successful in preventing viral rebound. And this is because, again, even in a setting where you start out with complete viral suppression, in this switch situation, 1 antibody led to selection eventually of resistant strains that were arising from the reservoir. So then we said, okay, so then we moved to doing a study where we combine our two antibodies in the same patient population. So in this study, we pre-screened individuals for sensitivity. We don't yet, in the whole field, we don't yet have a great assay where we can really truly identify who are the individuals that harbor sensitive viruses. This is different. The one thing that it's important to keep in mind is that in someone who is chronically infected with HIV, they are developing their own antibody responses. So it may be, so their viruses are under antibody pressure. So even though they may not have exactly the same antibodies as we are transferring to them, their viruses might have evolved in a way that they have become resistant to either or two of these antibodies. So this is one of the biggest challenges of using these antibodies clinically. So what we found is when we screened our participants by looking at their viruses that we could grow out of their PBMCs, we found that about 50% of the chronically infected patients that we looked at had expected sensitivity to the two antibodies. And then out of this pool of individuals, we enrolled 15 of them into the study. And then what we did in the study was they all came on ART, and they had very good CD4 counts to start with. They discontinued ART 2 days after they received infusions of the two antibodies, and then they were monitored every week until viral rebound occurred. And they received a total of 3 doses of the antibodies over a course of 6 weeks. And then we followed them for a total of 30 weeks. We were interested in seeing not only the ability of the antibodies to maintain virus suppression, but also to see if there would be any effect on the reservoir. And then we looked at the reservoir by different assays, and 3 months apart. So before they received the antibodies, and then at 12 weeks. And basically what we found is that we did better with this combination of two antibodies than we had done with our monotherapy study. So again, this is the same type of Kaplan-Meier curve that I showed you earlier. In black are what would be expected from historical controls if we were just to discontinue ART without any intervention. So most people will rebound within 4 weeks of discontinuing ART. This is the delay that we found when we used 3BNC117 alone. And this is what we find with the two antibodies in combination. But you can see, so there was a more prolonged delay in viral rebound. However, if we look closely, we can divide this Kaplan-Meier curve in two different groups. People that rebounded early, and then we call early people that rebounded within 12 weeks of discontinuing ART. So this is a period of time when we know that the antibody levels are high. So it was expected that rebound in this earlier period meant no, that possibly selection of resistant strains had occurred. And then there are the late rebounders that rebounded any time after 12 weeks. So out of the 15 individuals enrolled, 6 of them were what we called early rebounders. And then we saw two patterns. There were 4 people that had this viral blip, so they had viral loads of 50 or 20 or 30 in the few times that we brought them in before they discontinued ART. So, well, before I go into that, let me explain what each of these plots show. So this is, so the plots are showing black are the viral load curves. Blue are the antibody levels. So blue is 1074 levels over time. And then in red, 3BNC117 levels over time. And then gray is the period of time when they are on ART. So, so in these 4 antibodies, you see that the viral load increased, went above our trigger to restart them on ART, while both antibodies were still on board at pretty high levels. And then these 2 other individuals, even though they had completed virus suppression before they discontinued ART, they also rebounded within 12 weeks of discontinuing ART. So if we were to plot these 6 individuals back into our Kaplan-Meier curve, we see that the lines now of our monotherapy study and our combination study now, they overlap. And the reason for that is well, I'll explain what the reason is. So we were struck by seeing that we had these breakthroughs because we thought that we had pre-screened, and then we were expecting that we were going to have a higher rate of response because we were selecting people that were expected to have sensitive viruses. But when we applied a different way of looking at what the viruses that are in the reservoir, then we learned something more. So the assay that we use, we call it Q2VOA. So basically it's a viral outgrowth assay where we plate CD4 cells in a limiting dilution way so that you end up with you're able to isolate on average 30 sequences from these infected cells, so it gives you a greater representation of what's in the latent reservoir. And then once we have these viruses, we can look at the viruses phylogenetically, so we can look at its sequences, and we can also measure the reservoir by measuring the number of infectious units per million CD4 cells, and we can test these viruses for neutralization. So we are able to get all of these measurements. So in this assay was developed by Julio and Yehuda, and then Pilar Mendonça, she was the postdoc in the lab that conducted all the experiments related to this study. So when we looked, so all of these boxes are showing IC50s and IC80s, so the amount of antibody that was required to block each of these viruses in each of these roles with one antibody or the other. So the color coding is that the closer that you are to red, the more sensitive you are, and then white shows there is no neutralization at all. So and these are the 6 individuals that did not maintain suppression for a long time. And then what we find is that even though we had pre-screened them, when we looked more deeply into their reservoir, we find in all cases that there are viruses that are not neutralized. They're completely resistant to either one or both of the antibodies. So it shows that our screening method did not have sufficient depth to look at what was in the reservoir. And then in these 2 individuals, even though there is still some neutralization with the antibodies, the IC50 or IC80 was very high, and then IC100 was not reached in some of these viruses. So it explains that why they didn't respond, because they were not sensitive to both antibodies. So effectively, they were receiving just monotherapy. Now, what happens when we look at our 9 responders? So again, it's showing the same plot where we see in black viral load over time, and then the color lines are the antibody levels. Here we see 3 different patterns. So we see participants that maintain viral suppression until 3BNC, which is the antibody that has the shorter half-life, is cleared from the system, and then they have a period of 1074 monotherapy. So eventually they also select resistance, and then they have viral load rebounds. There are individuals that maintain suppression until both antibodies are cleared. And then there are these 2 individuals that completed the study at 30 weeks of ART discontinuation, and they did not experience rebound. So if we were to plot only these 9 responders, then we can really appreciate that we are successful in maintaining virus suppression for a longer period of time. And the median time was almost 4 months after the last doses of the antibody infusions. And then in none of these individuals, viral rebound happened when the 2 antibodies were present at levels more than 10 micrograms per ml. So this gave us this gave us data to now do some dosing adjustments as we go forward with different studies. So just to illustrate, one of the participants, which experienced viral rebound during the period of 1074 monotherapy. So again, this is showing the different viruses that are isolated from their reservoir, and then their neutralization sensitivity. So before the antibodies, you see that the viruses were in general very sensitive to both antibodies, but at rebound, there was complete selection of 1074 resistance, which makes sense because rebound occurred after 3BNC had been cleared, but under 1074 monotherapy. So in conclusion from this study, when we gave the 2 antibodies in combination, we found similar safety profile to giving either antibody alone. When they were administered at these 3 doses over a 6-week period, we were able to maintain suppression in 2/3 of the individuals, more or less, for a period that ranged from 15 weeks all the way to 30 weeks after this ART discontinuation. And once again, we found that we did not have any instance where resistance to the 2 antibody emerged. And in general, resistance did not emerge as long as the antibodies were below 10 micrograms per ml. Okay, so that is where we are in trying to see where we can go with the antibodies for treatment. But the last part is, can these antibodies really be part of what's called HIV eradication strategies? And then we can think about these strategies there are two different ways of thinking about how to achieve HIV eradication or long-term control. One are strategies that are aiming at sterilizing cure. So in these strategies, the goal is to eliminate the reservoir, essentially. And then these are based on shock and kill approaches. So these are approaches that combine agents that can induce viruses out of latency with approaches that can then come and eliminate the viruses that start replicating. And if we were to plot in a graph, this is what it would look like. So the individuals would be on ART, so they have achieved viral suppression, but we know that there is still residual virus. They would receive the latency reversing agents that would then induce some level of viral replication, so now making the virus apparent to other strategies that can come and then eliminate these viruses. And then these strategies could be either inducing better CTL responses with vaccines or immune modulators, or you could use these antibodies to clear the viruses that are purged out of the reservoir. And then by reducing the reservoir, you would delay viral rebound, or you would prevent rebound completely if you were successful in eliminating the very less infected cell. And this is a very high bar. But the other way of thinking about eradication is not really eradication, but rather what's called functional cure, or a term that is more in favor nowadays, which is drug-free long-term viral control. So the idea here is that you would combine strategies that would induce some level of reservoir reduction, but more importantly, these strategies would modulate immune responses in such a way that you could achieve long-term virologic control by immune responses, like it's achieved, for example, in elite controllers. So the idea here is that you would induce elite control by the combination of the modalities that you use. So here, the concept would be that the individuals would be on ART, they would receive vaccination or antibodies in combination with other immune modulators. They might experience a period of transient viremia, but because you modulated their immune responses, these immune responses would lead to viral suppression and long-term control. And then an alternative way of doing this would be to discontinue them from ART, change them over to BNAbs with or without immunomodulators, and achieving this long-term control by controlling with CTLs. So there are two animal studies that tested these concepts. In one, the antibodies were given during acute infection without ART, and the animals achieved viral suppression. After the antibodies were cleared, they had a period of transient viremia, and then in half of these animals, they achieved viral control on their own. And then the investigators found that if they deleted their CD8 cells, there was viral rebound, illustrating that perhaps the long-term viral control in the subset of animals was mediated by CTL responses. In contrast, there was a recent study done with another antibody where the animals were first suppressed on ART, and then they received the antibody alone or in combination with a TLR7 while on ART suppression. The interventions were they are allowed to clear all the interventions, and then they discontinued ART. And then they found that there was, again, in a subset of animals, they never rebounded. And what this group is proposing is that here with the intervention, you induce very small reservoirs, and that is why you avoided viral rebound and then achieved this long-term viral control. So now there are these two schools of thought where you can have long-term immunologic control, and then you might use BNAbs in the absence of complete ART suppression, or you should use BNAbs under ART suppression to achieve very small reservoirs. And then what is known in humans? So in 2 studies that used antibody monotherapy and measured antibodies over time, so here the antibodies were given under ART suppression, the various assays that were used do not show any changes in reservoir size. In our study with the 2 antibodies used in the absence of ART, we also don't find a significant change in reservoir size when we are measuring this by IUPMs or viral outgrowth assays. But one thing that we found that is interesting is that when we look at the clonal structure of the reservoir, we find that there are fluctuations of clones over time. So when we look at clones at baseline compared to 3 months later, even though the overall size of the reservoir didn't change, in some of the individuals, the clones either disappeared or they became smaller or they became more predominant, suggesting that perhaps the reservoir is not as stagnant as once thought, and then perhaps the reservoir is more targetable by different strategies. And this is again illustrating how when we looked at, this is a phylogenetic tree of 2 different patients, each little square is a virus that was isolated, either at baseline or 12 weeks later. So we see that there is this intermingled of sequences at both time points, but the rebound viruses were not exactly the same as what we found in the reservoir. And we still don't understand what that is. And here we are showing, just illustrating that for each of these individuals, there was an overlap of sequences that were isolated, that were identified by DNA or by viral outgrowth assay. And depending on the patient, there was more or less overlap of these latent viruses. However, the rebound viruses, what comes into plasma, is not quite the same. And we don't understand what that is, but I just put it there because it's one of our findings. So far, none of the antibody studies have shown a significant change in the reservoir size. However, and then we and many other groups have now shown that the reservoir has these clones of viruses, and these clones are dynamic, and therefore perhaps they can be targeted. In terms of immune responses, what is known, we have one study where we looked at antibody responses over time. And basically what we found is, what this graph is showing is how the person's own antibody responses changed over a period of 6 months. So in individuals that had not received the antibody, their own antibody responses either got better or worse over time, whereas after they received 3BNC117, we show overall an enhancement or improvement of antibody responses. And then perhaps this is due to what's called a vaccinal effect. So the antibody that we gave formed immune complexes with circulating viruses and induced better antibody responses. Or perhaps the antibody exerted pressure in the viruses and exposed new epitopes that led to better humoral responses. So that's what we know in terms of effects on antibody responses. Now, in terms of T-cell responses, we don't have data yet, but we are looking very closely at these 2 individuals that we had from our combination ATI study that finished the study at 30 weeks without experiencing viral rebound. And then one person now is past 54 weeks of discontinued ART and still hasn't rebounded, so he continues to maintain suppression. And this other person did rebound at week 52. So, but these times are far away from antibody clearance. So we are very interested to see if in these individuals perhaps there was changes in T-cell responses. So in general, we know that antibodies theoretically can engage the host immune system. We have data showing humanized mice that this is true, that these antibodies do engage ADCC and other type of FC effector functions. In humans, we have shown that one of the antibodies enhanced humoral immune responses. In animals, there is data suggesting that antibodies can lead to long-term control that is mediated by CD8 responses. And then we are studying very carefully the 2 patients that we have that maintained virus suppression for a long time after the antibodies. And just to finish, I think there is a lot of excitement about these antibodies and the potential that these antibodies might have in HIV infection, but there are significant challenges. So as I try to illustrate, perhaps the biggest one at the moment is the existence of pre-existing resistance and the fact that we don't have perfect assays to identify the individuals that would respond respond and respond well to the antibodies. But many groups are working on developing such assays. We know that we have virus escape if we give only one antibody. 2 antibodies appear to be sufficient if we are switching from ART suppression to the antibodies. But will this really be the case if we are to give the antibodies over a long period of time? We don't really know what the penetration of these antibodies are in different tissues. Specifically in the CNS, these antibodies are not expected to penetrate the CNS effectively or almost at all. ADA, which is immunogenicity with repeated dosing, might become an issue when these antibodies are given over a long period of time. And the community continues to have concerns in terms of we know little so far about their safety, their efficacy, and then these are antibody molecules. So the question that always comes to mind is what's going to be the future access to these modalities. So this is the work of a lot of people. So I work in Michel Nussensweig's lab. The experimental work is done by postdocs in his lab, and this is our clinical group. And we work very closely with collaborators at the University of Cologne, and we have funding from different sources, especially from the Gates Foundation and NIH. Thank you.
Thank you, Marina, for these excellent presentations. Estamos un poco fuera de tiempo, entonces, bueno, yo creo que podemos tener tiempo para una pregunta. Pepe.
Thank you, Marina. I have one question. In the phylogenetic analysis of these resistant viruses, the pre-existing resistant viruses, are these viruses closer to the transmitted viruses, are viruses that have an evolution in the host?
So we haven't looked at them in that way. It's expected that when we look at pools of transmitter founder viruses, we're going to have less resistance, but we know that there are transmitter founder viruses that are resistant. But we haven't looked at our viruses in that way to see how close they would be to TF8s. But that's a good, interesting question.
Bueno, pues muchas gracias. Yo creo que lo vamos a dejar aquí para tener tiempo para el café. No sin antes agradecer a los ponentes bueno, pues sus excelentes presentaciones, a todos vosotros vuestra participación y, por supuesto, a mi compañero de mesa, Antonio Rivero, que siempre es un placer trabajar con él. Muy buenos días.